Hey everyone, here's an example from section 3.2. This is a solving quadratics problem. It says consider the equation x squared plus 113 equals 20x. Complete the following. Write the equation as ax squared plus bx plus c equals 0. So for part A, the first thing I want to do is I want to take this equation and I want to write it in the form of ax squared plus bx plus c, which is standard form. So I'm just going to subtract the 20x over to this side, and that'll get that into that form. So that'll give me x squared minus 20x plus 113 equals 0. So that's part A. Part B then, it says calculate the discriminant b squared minus 4ac and determine the number of real solutions. So I'm going to take this b squared minus 4ac formula, I'm going to write it here, and I'm going to write down what a, b, and c are. A is 1 because that's the leading coefficient on the x squared term. B is negative 20 because that's the coefficient on the x term, and c is 113. And I'm going to use this form, this discriminant, to figure out how many real solutions this equation has. So b squared, that's negative 20 squared minus 4 times a times 113, which is going to give you 400 minus 4 times 113. That's going to be 452. Subtract that, you're going to get negative 52. So actually, because I got a discriminant that's a negative 52, this is not going to have any real solutions. This is going to be we're going to have imaginary solutions, complex numbers for solutions. So this negative 52, because it's less than 0, so if a is less than 0, then this is going to have no real solutions. So this is actually an example from section 3.3. So the first thing I said was an example from section 3.2. Because I got this is the complex number, so that's section 3.3. But now they're going to ask us to actually solve the equation. So what I'm going to do is I'm going to write down the equation. So I've got x squared minus 20x plus 113 equals 0. And now I'm going to use the quadratic formula. And we know the quadratic formula is b squared, or no, negative b plus or minus square root of b squared minus 4ac all over 2a. So if you look, the discriminant, if you notice here, was negative b, or was b squared minus 4ac. This is why we have no real solutions, because when we calculate the discriminant, that's actually calculating the same thing that's underneath the square root in our quadratic formula. If we get a negative underneath the square root in our quadratic formula, well, we can't take the square root of a negative, so that's going to be no real solutions. I should say we can't take the square root of a negative without getting the complex number I as part of our answer. So let's go ahead and use now, I want to use this negative 52, so I'm going to say that b squared minus 4ac, I already know that that equals negative 52, and then I'm going to plug in the rest of the problem. So they want me to solve the equation. Let's see here. We know that from before, a is 1, b is negative 20, and c is 113. So we're going to plug in b squared, which would be, no, negative b, which would be negative 20, plus or minus the square root of negative 52, because remember that's our discriminant, over 2 times a, so 2 times 1. That's going to give us 20 plus or minus square root of negative 52 over 2, which then is going to give us 20 plus or minus. I can change it. I have a square root of -1 here. Square root of a negative we know is going to be I, so I'm going to have I out front. Now I just need to break down 52. So what does 52 break down into? I can make that 2 and 26, 2 and 13. Notice I have 2 2's there, so I can write that now as 20 plus or minus 2I square root of 13 over 2, which then breaks down to 10 plus or minus I square root 13. And that'd be our answer. They might ask you to write this in the computer as two different answers, which would be 10 plus I square root 13 and then 10 minus I square root 13.